Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes. Coming to the problem statement. A circular lamina of 50 diameter rests on HP such that one of its diameters is inclined at 30 degrees to HP and 45 degrees to VP. Draw the top and front views of the lamina. So, looking at the problem statement, we can arrive at a set of conclusions. The first one being the type of lamina given to us here is a circular lamina, and the resting condition is it is resting on one of its diameters on HP, and also this particular diameter is inclined to HP at an angle of 30 degrees and also to VP at an angle of 45 degrees. And we need to draw the top and front views of the lamina. So, looking at the problem statement, we can just understand here that the entity which is considered for the inclination with respect to the VP as well as the HP is the diameter, and this diameter is going to change its length whenever it is going to be inclined with respect to the HP and VP compared to its initial position. So, since we are going to consider the parameter which is going to change its length when we are going to incline it with respect to the HP and VP, we have to consider it to be a beta angle problem. And also, the word appears to be inclined at 45 degrees to VP is not given here. So, the given angle is phi and not beta, and we need to construct the beta angle for this. So, first, we will draw the XY line of any arbitrary length and annotate the line as XY and also the reference planes as VP and HP. And now we will draw the top view of the circular lamina such that it is resting on the HP on one of its diameters. So for that, let us select the circle by center point option. And since the top view is completely visible to the observer on any arbitrary point, we are going to mark the center of the circle and draw the circle of diameter 50 And now, since the circle is not having any sharp corners, we need to identify minimum 8 points on the circumference of the circle in order to get the top and the front views in the consecutive positions. So for that, let us draw the vertical diameter and the horizontal diameters and then divide the circle first into 4 equal parts, and later on draw the diameters at 45 degrees and divide the circle into 8 equal parts. So now I'm going to draw the radii of the circle of 25 and then the radii of the circle 25 in the vertical direction. So using the extend option, I'm going to extend the radii to be the diameters in the horizontal and the vertical positions. And next, I'm going to draw the radii from the point of intersection, that is the center point, at an angle of 45 degrees. Similarly, I'm going to draw one more radii of 25 length and then at an angle of 135 or 45 degrees. So now using the extend to next option, I'm going to extend this diameter. So now I've got 8 unique points on the circumference of the circle. So now let me annotate those points. So this is point A, this is point B, point C, D, E, F, G, and H. So these are the points. And now let me draw the vertical projectors so as to get the front view of this particular circular plane. So from the point A, from the point B through the point H, intersect the XY line. Similarly, from the point C through the point G, intersect the XY line. From point D through the point F, intersect the XY line. And then from the point E, intersect the XY line. So now we are going to draw the front view of this particular lamina. So for that, let us consider the trim option and trim this portion of the XY line, and selecting the line option of thickness 0.50, let us connect the end points of all the vertical projectors to get the front view of the circular lamina. So we will annotate the front view. So this is A dash, and here the point B is visible to the observer. So B dash, and H dash is not visible, so inside the bracket. And similarly here the point C dash is visible and G dash is not visible, so inside the bracket. And here the point D dash is visible and F dash is not visible, so inside the bracket. And here the point E dash is visible, so it is a single point. So now we'll just try to arrange the letters with the corresponding endpoints. So this completes the front view of the circular plane lamina when it is resting on one of its diameter AE. So the right point is my reference point and the diameter passing through that point is AE. Okay, so now as per the problem statement, it is this diameter is inclined to the HP at an angle of 30 degrees. So for that, I'll select the front view of the circular plane lamina along with the annotations, and then select the move option, ensure the copy is on, and keeping A dash as the reference point, I'm going to move it towards the right hand side of the XY line, and then using the rotate option, let me rotate the diameter AE at an angle of 30 degrees as given in the problem statement. So 30 degrees with respect to the HP. So ensure the copy is off, and this completes the rotation of the lamina. So now we shall draw the projection lines to get the top view in this position. So from the point A, similarly from the point B and H, and then from the point C and G, from the point D and F, and finally from the point E. So ensure all the endpoints are connected and all the vertical projections are minus 90 degrees. And then let us draw the horizontal projections. So from D through the point B, let it intersect the projection of B and D, and then projection from C. So all the horizontal projections must be 180 degrees or 0 degrees. And then this completes the projections from all the 8 points on the circumference of the circle. So now the circle is going to appear as an ellipse. So for that, let us select ellipse by 3 points, and then thickness should be 0.50. So let us select the extreme points on the minor diameter of the ellipse. So this is the first point and the point of intersection, second point, and the next point will be the end point here. So use the zoom option and then ensure you're going to touch the end point of this projection line. So now you can just see that the ellipse is ready. So now we shall annotate this ellipse. So identify all the 8 points again, that is A to H. So this completes the top view of the circle plane, which is inclined to HP at an angle of 30 degrees. So now we are going to consider the beta angle construction. So before that, now let us try to understand the concept. So why it is a beta angle? So let me measure the diameter in this position, it is 50 mm. But when I measure the diameter here, you can just see that the diameter has been reduced to 43.3 mm. And we are going to consider this entity which has changed its dimension for the inclination with respect to VP. So obviously we are going to consider it to be a beta angle problem because we are going to construct the inclination by considering an apparent inclination. So for that, let us select the line option and draw a line of any arbitrary length, and the line shall have a thickness of 0.13 mm. So this is the line, and then from the line let us draw the initial diameter, that is 50 mm, at the given angle of phi, that is 45 degrees with respect to the VP. And from the end point, let us try to draw the locus line. So this is the locus of the point E. So using the annotation, let us annotate the reference point as A and the end point as E, and this is the locus of E. So now the next step is we need to construct the beta angle. So for that, we'll select the arc by center point. So this is the center of the arc, and here we are going to draw an arc of 43.3 mm, which is the radii of the arc, which is nothing but the diameter of the circle in the second position. Correct? So now let us draw the arc to intersect the locus of E. From the point A, it is going to intersect like this. So from the point of intersection, so select the arc once and the line, and next extend that line to the point A, and this is the angle of inclination. From here till here, it is going to give us the value of beta angle, which is 55 degrees, and this is the value of phi, which is given to us, which is 45 degrees. Correct? So now with the beta angle constructed, we are going to draw the beta angle. So let us draw a line which is inclined to the VP at an angle of minus 55 degrees. So select the angle between and measure the angle which is equal to 55 degrees. On this line, I need to have the diameter AE inclined. Okay, so this is the diameter which is inclined to HP at an angle of 30 degrees, and it appears to be inclined at an angle of 55 degrees. So this is the apparent inclination angle. So now we are going to use the trim option so that we can select this ellipse freely from all the projection lines. So we'll just use the trim option so that we are going to keeping point A as the reference point, move it on the 55-degree inclination line. So now we are going to select the rotate option, rotate keeping A and E as the measurement, and ensure the copy is off. So now you can just see that the diameter which was inclined to HP at an angle of 30 degrees is also inclined to VP at an angle of 45 degrees. Okay, so that is the angle phi, but since the diameter has changed its dimension, we are going to consider the beta angle which has found to be 55 degrees. So now we'll complete the projection lines using the extend to next option. So now we will draw the vertical and the horizontal projectors to get the front view of the ellipse or the circle. So this is the projection from E, and then point D and F, CG, BH. So the point A will be on the XY line. Next, coming to the point B. So if this confusion is there, just enter the angle of projection as 90 degrees so that it will be a straight line. So next from point F, point G, then point H. So now in the curve option, select the curve option and let us select the thickness to be 0.50 because it is the front view which is visible to the observer. So the starting point is A, and then followed by B, C, D, end point E, end point of projection from F, G, H is here. So it is pass from, okay, H is here. And next this is back to A. So with this, we have completed the front view of the circular lamina. Now let us annotate the points. So this is A dash, this is B dash, followed by the point C dash. This is D dash, E dash. This is F, and this is G dash, and this is H dash. So ensure all the annotations pertaining to the front view are above the XY line. So using the trim options, let us just trim the lines which is not required for us, the projection lines which is not required for us. So now we'll indicate the direction of the projection lines using the leader option. Let us change the color of the arrowhead to black and indicate the directions of the projection lines. So with this, we have completed the problem, which stated that there is a circular lamina resting on one of its diameter on the HP, and its diameter was inclined to HP at an angle of 30 degrees, and also it was inclined to VP at an angle of 45 degrees. So we have constructed the beta angle, and then we have completed the